Hi! This instructional video is about writing linear equations. Linear equations in slope-intercept form. In this case, what we're trying to do is write the equation that is going to be parallel to this equation. Yeah, this is the one that students are confused by. So in order to see this, let's go ahead and graph this function. Y is equal to negative 11. Y is equal to 2x minus 11. Here it comes. Check this out. So I'm going to draw a coordinate plane, and I'm going to give a little more space on the quadrants 3 and 4 because I want the y-intercept to be at negative 11. So here we go. There. So negative 11 is the y-intercept. This is the b. This is the y-intercept. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is negative 11. Bam! Can you see that? Barely? Yeah, let's this time bring the camera down a little bit. Ta-da! There it is. So it's way down here. And we're going to have a slope. This is the slope. Slope is the ratio of rise over run. So from here, we're going to go up 2 because 2 can be written as 2 over 1. Rise is 2, 1, 2, and then the run is positive 1. So to the right, 1. We could repeat that process. 1, 2, 1. 1, 2, 1. See, we could keep going on and on. So if we draw a line through at least 2 of those points, we're going to have a slope that's going to be going up from left to right in a ratio of rise over run 2 over 1. There it is. So there's the graph. Now what they're saying is, come up with the equation that's going to be parallel to this guy. So you have to understand, what is parallel? What is parallel? What train tracks are parallel to each other? If they weren't, ooh boy, we're going to have some problems. So we're going to draw a line that's parallel, but it's going to go through the coordinate 3 and 4. So where is that? So it is going to be at, from the origin, 1, 2, 3, 1, 2, 3, 4, way up here. Kind of messy, but nevertheless, it's right there. So how do you make it so it's parallel? It has to look something like this, doesn't it? See? It has to look like that, so it's parallel. That's what they're asking. Not anywhere, but it has to go through at this coordinate, which is right there, 3 and 4, and has to be parallel to the original, right there. Now I could draw it, but how do you write the equation? Enter the point slope form. Yeah. Which is y minus y1 equals m times the quantity of x minus x1. We did that on a previous video. This is why you need to know this. Y and the x are the placeholders. The slope, now here's the thing about the slope. You see this was 2, 1, 2, 1. Well, if the two lines are parallel, this also has to be 2, 1. From here, 2, 1, 2, 1. That's the only way, 2, 1. It will stay parallel. So it has to have the same slope. So what that means is we're going to take this slope right there and we're going to use it in here because they have to be parallel to each other. So the 2 goes here. X minus. What's this x1? It's the new point. There it is. This is your x1, y1. So 3 goes here. Then what's this y1? That's the 4. There it is. Now we're going to evaluate. Look, there's a number outside the parentheses. So we're going to do the distributive property. 2 times x, 2x. 2 times negative 3, negative 6. And on the left side, we had y minus 4. Now to solve for y, we're going to move that negative 4 by adding 4 to both sides of the equation and lining them up with the like term, the constants. So negative 4 plus 4, they become 0, they cancel out. Y becomes 2x minus 2. That becomes the equation that is parallel to this original, and they have to have a same slope. Let's graph this to see if they are in fact parallel. The y-intercept on this one is now negative 2, not negative 11, but over here, negative 2. And if I draw this point, the y-intercept, through the given point, which was 3 and 4, look what I have. Look what I have. Voodoo magic. Ooh, no, mathematics. See, from here, up 2, 1, up 2, 1, up 2, Shazam, right there. Parallel, point slope form. Enjoy.